Today's lecture will be about how programmers work in real life, and we'll learn how to design a program, and also we'll write the program and execute it. So this should be an interesting session. I think it will last 3 lectures of 10 minutes each. So this is the first one. Now, the topic that I chose is something that you're familiar with, but I will probably have to refresh your memory, and we discussed it before. It's the hexadecimal counting system. If you remember, we talked about base of 16, which is the hexadecimal, and in hexadecimal we can write numbers, for example A9 or B, D, 4, F. So just a reminder, we have all the digits from 0 to 9, normal digits, and then after 9 comes A, and then B, C, D, E, F, and after F we have 2 digits. It's a 10 in hexadecimal. To mark it as hexa, we normally put an X after the number. So 10 in hexadecimal equals to 16 in the decimal system. I'll just write decimal for decimal. Sorry, it's 16 in decimal. So because we don't have more than 10 digits, they invented the letters A to mean 10, B to mean 11, C to mean 12, D is 13, E is 14, F is 15. And then we don't have 16, but we have the 10. 10 in hexa means 16 in decimal. And I also showed you how to convert from hexadecimal to decimal. For example, if we have the number 20A in hex, how do we convert it? Okay, we start from the right hand side and we take digit by digit and we multiply it by the power of the place where it is. So the first digit is A, and A is actually 10 in decimal. So we'll do 10, and we don't have to multiply it with anything. Actually, we multiply it by 1 because the first digit is always the single digits. The second digit is already 16 because it's 16 to the power of 1. This is 16 to the power of 0, which is 1. This is 16 to the power of 1, which is 16. And then we do plus 2 times 16. So this will give us 10 plus 32, and the final result is 42. So the number 2ax in hexadecimal is equivalent to number 42 in decimal. Let's try another example, more complicated. Let's do the number DA5 in hex. How do we convert it? The same way, we take the 5 is the singles, multiply it by 1, plus, next one is A, and A we know is like 10 in decimal, so we do 10 and times 16, and the next one is D, and D was if A was 10, B was 11, C was 12, D was 13. And now we have to multiply it by 16 times 16. Because when we go to the left, every time we go one digit to the left in the hexadecimal number, the value of that digit is more. If it was decimal, the value just multiply by 10. But because it's hexadecimal, the value multiplies by 16. Remember, we used to write above the number, we used to write the value of the digits, and we said this is multiplying by 1, the 5, and then the A multiplies by 16, and the D multiplies by 256, which is 16 times 16. So after we finish this multiplication and addition, we'll get a big number, and you can calculate it yourself, and this is the conversion of the number DA5 in hexadecimal to a number in decimal. So why am I reviewing this topic of hexadecimal to decimal? Because the program that we want to write, or design in this case, and then write, is a program which will be actually a function, and the function I'll call h to I. C has few functions that convert numbers, like character to numbers. For example, it's called a to I. A to I. What a to I does, for example, if we have the string 1, 2, we can convert it to the number 12 by using the function a to I. So now we want to create a new function that C doesn't have, and that function will be called h to I, and the specification for this function are going to be return value, integer, and parameter is also integer. Sorry, parameter is not integer, but it's a character string. So, for example, we want to give h to I a parameter, and let's say a x, we always finish it with x, and we want to get back from h to I the number 10. Or another example, if we give h to I the string ffx, which means ff in hexadecimal, we want to get back the number 255, because ff in hexadecimal, if you multiply, f is 15, 15, and then 15 times 16, and you will add them, you will get the number 255. So this is what we want to do with h to I, and since I'm running out of time for this session, I will continue in the next session, where we'll talk about the design of the function and we'll start writing it. So this is it for this particular one, and please see the next one if you want to continue with the subject.